That large green caterpillar on your tomato plant did not kill your plant. Your plant was already dying before she arrived. She is a symptom reader. What she found on your tomato tells you exactly what went wrong 3 weeks ago. What it actually is. The tomato hornworm is the larval stage of the 5-spotted hawk moth, Manduca quinquemaculata, one of the largest moths in North America. The caterpillar reaches 4 inches in length at full development and carries a distinctive curved horn at its rear end that has no functional purpose beyond startling predators. It feeds on solanaceous plants exclusively. Tomatoes, peppers, eggplants, and potatoes are its only host species. A hornworm appearing on a healthy, well-watered, adequately fertilized tomato plant causes visible defoliation, but rarely kills the plant. A hornworm appearing on a stressed plant accelerates a decline that was already in progress before she arrived. What stressed plant means? A tomato plant under physiological stress produces chemical signals through its leaf surface that are detectable by female hawk moths during egg-laying flights. Specifically, plants experiencing calcium deficiency, inconsistent watering, or early fungal infection emit elevated concentrations of volatile organic compounds, including methyl jasmonate and ethylene, that healthy plants emit at lower baseline levels. Female hawk moths use those elevated chemical signatures as oviposition cues. They preferentially lay eggs on plants already showing the early biochemical markers of stress or disease. The caterpillar you find on your tomato was placed there deliberately by a moth that detected your plant's distress signal from the air before any visible symptom appeared on the surface. The real killer. The plant decline most gardeners attribute to hornworm feeding has 3 actual causes that precede the caterpillar's arrival by 2 to 4 weeks. The first is early blight, a fungal infection caused by Alternaria solani that establishes in the lower leaves and progresses upward through the canopy. Early blight reduces the plant's photosynthetic capacity before any visible yellowing appears at the leaf surface. The second is inconsistent watering that creates blossom end rot through calcium transport disruption inside the plant's vascular system. The third is root zone compaction that restricts oxygen and water uptake at the root level. All 3 conditions weaken the plant's immune response and trigger the elevated volatile emissions that attract egg-laying moths. The caterpillar arrives into a plant that has already lost the physiological capacity to recover. The parasitic wasp connection. A tomato hornworm covered in small white rice-shaped objects on its back is not a pest that needs to be killed. Those white structures are the cocoons of Cocoons congregatus, a parasitic braconid wasp that has already doomed the hornworm from the inside. The female wasp injected her eggs directly into the hornworm's body using her ovipositor. The larvae hatched inside the caterpillar, fed on its non-essential tissue to avoid killing the host prematurely, and then chewed through the skin to spin their cocoons on the exterior surface. The hornworm carrying those cocoons will never feed again. It is already dying. The wasps emerging from those cocoons will immediately seek new hornworm hosts across your entire garden. Killing a parasitized hornworm destroys between 50 and 200 emerging parasitic wasps that would have protected every tomato plant in your yard for the rest of the season. What pest companies miss? A pest control technician responding to a hornworm complaint applies a contact insecticide to the tomato plant foliage. The most commonly applied product for caterpillar control in residential garden settings is a pyrethroid spray or a spinosad formulation. Both kill the hornworm on contact. Both also kill Cocoons congregatus wasps on contact. A parasitized hornworm sprayed with either product dies before the wasp cocoons complete development. The emerging wasps are killed inside their cocoons by residual chemical on the hornworm's exterior surface. The garden loses between 50 and 200 parasitic wasps per treated hornworm. A garden with 3 treated hornworms loses up to 600 individual parasitic wasps in a single service visit. Those wasps would have dispersed across the property hunting new hornworm hosts through the remainder of the season. The pest company charges between $80 and $150 for the caterpillar treatment. the garden loses its biological hornworm control system for the season. Hornworm populations rebound without parasitic pressure within 3 weeks. The soil diagnosis. The hornworm's presence on a specific plant within a garden containing multiple tomato plants tells you which plant has the most advanced stress condition. Hawk moths conducting oviposition flights sample volatile emissions from each plant individually before selecting a laying site. The plant that receives the highest egg density is the plant emitting the strongest stress signal. That plant is your early warning indicator. If hornworms are concentrating on one tomato plant while adjacent plants remain untouched, the infested plant has a root zone, watering, or fungal problem that the adjacent plants have not yet developed. Dig 6 inches into the soil at the base of the infested plant. Compacted gray soil with no visible earthworm activity indicates anaerobic root zone conditions from overwatering or compaction. Dry, cracked soil pulling away from the stem base indicates chronic underwatering despite surface irrigation. White mycelial threads visible on the root surface indicate fusarium or pythium infection already established in the root zone. The hornworm told you where to look. The soil tells you what is wrong. Biological control system, Cotacea congregatus, is not the only parasitic species that uses the tomato hornworm as a host. At least 14 documented parasitoid wasp and fly species target Manduca quinquemaculata larvae across its North American range. Each species has a slightly different timing window for host selection, creating a biological control cascade that covers the hornworm's entire larval development period from early instar through final stage. Early instar hornworms are targeted by trichogramma egg parasitoids that attack the unhatched eggs on the leaf surface. Mid-stage larvae are targeted by Cotacea congregatus and related braconid species. Late-stage larvae are targeted by tachinid flies that inject larvae directly into the fully developed caterpillar. A garden that has never received a broad-spectrum insecticide application maintains populations of all 14 parasitoid species simultaneously. That multi-species parasitoid community provides continuous biological hornworm suppression across the entire growing season without any input from the gardener. A single pyrethroid application to address a visible hornworm population disrupts all 14 species simultaneously because pyrethroid residual on plant surfaces contacts every insect that lands on treated foliage, regardless of whether it is the target pest or its natural enemy. What makes this parasitoid cascade particularly valuable is the self-regulating nature of the system. As hornworm populations increase in a garden with intact parasitoid communities, parasitoid populations increase proportionally in response to the elevated host density. The biological control pressure scales automatically with the pest pressure. No gardener intervention is required, and no product purchase triggers the response. The parasitoid community detects the hornworm population increase through chemical signals released by both the hornworms themselves and the damaged plant tissue they feed on. Those signals recruit more parasitoid females into the garden from the surrounding habitat. The system recruits its own reinforcements. The recovery timeline after a pyrethroid application disrupts this system is the detail the pest industry never discloses at the point of sale. Parasitoid wasp populations require between 4 and 8 weeks to re-establish at effective control densities after a broad-spectrum insecticide clears the garden. During that recovery window, hornworm populations experience uninhibited growth with no natural pressure controlling their numbers. The population that triggered the original spray call doubles and triples during the parasitoid recovery period. That population surge is what generates the follow-up treatment call 3 weeks after the first application. The pest company schedules the follow-up before leaving your driveway because the biology of what they just disrupted guarantees it will be needed. Plant recovery protocol, addressing the actual cause of tomato plant decline, requires identifying which of the 3 primary stress conditions the hornworm's presence revealed. Calcium deficiency and inconsistent watering produce blossom end rot as the visible symptom. The fix is not a calcium spray applied to the fruit. Calcium transport in tomatoes is driven by water uptake through the root system. A plant receiving inconsistent water cannot transport calcium from soil to fruit, regardless of soil calcium levels. The fix is consistent deep watering on a fixed schedule. 1 inch of water per week applied in 2 applications of half an inch each, delivered slowly enough to penetrate 12 inches into the root zone rather than running off the surface. A drip irrigation system on a timer achieves this for between $25 and $60 in materials for a standard garden bed and eliminates the watering inconsistency that triggered the stress signal the moth detected. Early blight identified through lower leaf yellowing with dark concentric ring lesions requires removal of all affected foliage below the first flower cluster, followed by a copper fungicide application to the remaining foliage at the label rate. Copper fungicide runs between $8 and $15 per bottle and provides 2 to 3 weeks of protection per application. Root zone compaction requires a single deep soil loosening with a garden fork to 12-inch depth, followed by a 2-inch layer of finished compost worked into the top 6 inches. That single amendment improves oxygen and water penetration through the entire root zone for the remainder of the season. The timing of these interventions relative to hornworm appearance determines whether the plant recovers or continues declining. A plant addressed within 5 days of the first hornworm sighting still has sufficient photosynthetic capacity and root function to recover through the remainder of the growing season. A plant left untreated for 2 weeks after hornworm appearance, while the gardener focuses on caterpillar removal rather than underlying stress conditions, has typically lost enough foliage and root function that full yield recovery is no longer possible for that season. The practical sequence is this: find a hornworm. Do not remove it if it carries white cocoons on its back. Check the soil moisture at 12-inch depth by pushing a finger or a wooden dowel into the soil beside the stem. Dry soil below 6 inches on a plant that appears watered at the surface indicates shallow watering that never reaches the deep root zone. Check the lower foliage for dark, concentric ring lesions. Check the fruit for soft, dark patches at the blossom end. Each symptom points to a specific fix that costs between $0 and $60 and takes less than 1 afternoon to implement. The hornworm told you where to look. The plant is telling you exactly what it needs. Seasonal value calculation. Here is what a healthy parasitoid wasp population protecting a standard residential tomato garden is worth across 1 growing season. A garden containing 6 tomato plants experiencing normal hornworm pressure without biological control loses between 20 and 40% of its foliage to hornworm feeding before the population peaks in midsummer. Foliage loss above 30% reduces fruit yield measurably by reducing photosynthetic capacity during fruit development. A 6-plant tomato garden, producing at full capacity, yields between 60 and 120 pounds of tomatoes across the season, depending on variety and growing conditions. A 30% foliage loss from uncontrolled hornworm feeding reduces that yield by between 18 and 36 pounds. At current grocery store tomato prices of between $2 and $4 per pound, that represents between $36 and $144 in lost yield value from hornworm feeding alone in a garden without biological control. A garden maintaining intact parasitoid populations through avoidance of broad-spectrum insecticide applications loses between 5 and 10% of foliage to hornworm feeding as parasitoid pressure limits population growth before peak feeding damage occurs. That reduced feeding loss translates to between $108 nows and $138 in recovered yield value compared to the chemically treated garden. The pyrethroid treatment that eliminated the parasitoid population costs between $80 and $150 per application and requires reapplication every 3 weeks as hornworm populations rebound without biological pressure. 3 applications across a season run between $240 and $450. The garden that never sprays spends $0 on hornworm control, maintains its full parasitoid community, and recovers between $108 and $138 more in tomato yield than the garden that paid $450 to destroy its own biological defense system. That is the calculation on the back of every pest control invoice that nobody prints. That is the complete picture. A caterpillar that arrived because your plant was already stressed, carrying a biological control system on its back that would have protected your entire garden, killed by a spray that cost $150 and destroyed 600 natural enemies in a single afternoon. Drop a comment and tell me what you did the last time you found a hornworm on your tomatoes. I read every one, and the answer is almost always picked it off and stomped it or reached for the spray. If you know somebody who has been fighting hornworms every season with sprays and losing tomato plants anyway, send them this video. The hornworm was never the problem. The spray was.